vector form, which is v1 and v2. So we can use these two vectors to do some calculation, add or subtract, and cross and dot product. I'm going to show you guys. This is very convenient in Mathematica because we already have v2 and v1. We can just use it as a calculator and do some calculation. For example, v1 So here is 2, one is add, one is minus, and the 2 dash here, and we add a command which is make matrix form, and it is only after the 2 dash here, it is only allowed to add command instead of some numbers and the other stuff. And here v1 and v2 we got 4 4 4, and v1 minus v2 we got minus 2 0 and 2. Now let's start dot product. Dot product is a command, and remember the first letter of command is capitalized. So dot, and we add command. It's v1, comma v2, and here we got 10. If you guys can see it. So it is very simple and efficient. You can just type dot v1 comma v2 and turn out to 10, which is the answer. And here's we got a cross product.就可以加那个后面加2个，把它转变成 matrix form 就可以了。
Yes.
And we can also do matrix form here. Yes. Here. Here is -4, 8, and -4, which we can do. We can test it by cross
by hand as well.
Yes. Yes.
你想给他们演示一下吗？
No.
No need.
No need to do it by hand when we have a powerful calculator.
Yes.
So our point making here is that Mathematica treats all vectors, because we can see that we have previously we defined 2 vectors. The first one is 1 2 3, and the second one is 3 2 1. What Mathematica do is it treats it like a list of numbers, which they treat it as an n×1 matrix. That's why we have a command called matrix form, which is lining them up vertically so we can put it as a matrix form. The brackets, the big brackets over here, symbolizes that it is a list of alike components. Because we know, for example, v2 is a 3-dimension vector, 3 2 1. So it is 3 is its x component, 2 is its y component, and 1 is its z component. So it treats this as a matrix because they are all alike components. They are all x, y, z components. So we put them in the big brackets that symbolizes it is they're alike terms, so we can combine them together. So now let's move down to other parts that are more useful in multivariable calculus. That we move down to the actual function part. I'm gonna abandon this thing because it's not that it's time preserving. So first, let's learn how to define a function. So to define a function, we have this command of f middle brackets x underscore. This is a way to tell Mathematica that, hey, this is a function. I'm going to define this function now. The underscore here tells Mathematica that, hey, we're going to introduce you to a new variable over here. So it is also when we were trying this out ourselves, we were want to remind you guys to take caution, because if you define x over here, and you want to define another function that has x, another function that has x in it, it's gonna overwrite. So this function will no longer persist if you define another function with x in it. So probably we can try it out, so we can also introduce some other things to you guys. In this function, we say f1 equals to f1, we define it, x underscore, column equal sign. The column equal sign tells Mathematica, hey, we're defining a function right now. This is the first time that it appears, and the column equal sign only needs to appear once. Only the time when you're defining this function. So let's say an easy function, x squared plus 5. Mind the color change here. The x in our actual function turns green. Now the green color means that Mathematica recognizes it. He knows that this is a variable that you have to define before. But why is f1 blue over here? Because Mathematica doesn't know what is f1. You haven't told it what is f1 yet. So now you run it, it turns back to black. So Mathematica says, hey, I know what f1 is right now. So this is the first step of defining a function.
Also, you can change the color if you want in the setting.
Yeah, but no need to confuse everyone. But now let's move on to our next part of finding limits. Let's say we want to find a limit to this function. Give me a random number, like x approaches what? Any random number.
Function you mean?
Yeah. Give me any random number.
6 I guess.
X approaches 6. So it is very convenient that Mathematica also has this built-in command. We say built-in command is limit. Find a limit. So our function is f1. So just tell it f1 of x, because we're finding about x. See, the x over here is blue again. What does it mean? It means Mathematica doesn't know what it is. You want to tell it that, hey, we're finding it about x. X approaches 6, we said. X approaches 6. Now it turns into sort of a blue-gray again. It means, hey, Mathematica recognize it. So now you can run it.
I would say it's green.
So the answer is 41. We can check it by our mind as well. 6 squared plus 5 is 41. So hey, there you go, your answer. And this is how you find a limit in Mathematica, which is very simple. But moving on to multivariable calculus, we're now dealing with graphs in 3-dimensional. So there are multiple variables. It's not going to be only x. So let's say a random function. Let's say, let's define another function of x and y. Remember, now I'm defining x again, which will overwrite f1. So our f1 will no longer exist right now. Colon equal sign, and then let's say xy squared divided by yx squared minus xy. Let's define this function. Okay, now Mathematica knows this function as well. But here's a tricky point. Why didn't I just type xy over here, but I type x times y? What will happen if I put xy? It turns blue. It's a new variable. Mathematica doesn't know it. That's why I need to put a times sign over here to tell it, hey, these are two different variables multiplying each other together. So now Mathematica knows it. But now we're gonna find this limit in 3 dimensions. And let's say a random point, 0, 1. We're gonna find a limit to this. It is still the same command, limit. We tell him f of 2, x and y. But now, remember, what are our big brackets for? For alike terms. X and y, they're both variables. They are alike terms. We put them in the same black bracket. xy approaches 0, 1. 0, 1 are points, so they're also alike terms. So we put them together. Let's run it. Hey, there we go, our answer. It's -1. Comes in. Okay. So there's your answer, -1. So this is how Mathematica finds limit in multivariable calculus. And also, there's a reminder, if the limit doesn't exist, because we know like all the time there's going to be a limit that doesn't exist, mathematics is going to tell you indeterminate. That's when you know that a limit doesn't exist. So now, another part of functions that are really important, derivatives. How are we going to find derivatives in Mathematica? It is another very simple command called d. But Mathematica only has this built-in command of a partial derivative. So no matter what degree this function is, you always have this. For example, let's have a simple function, sine of x. Remember, a command, the first letter must be capitalized, sine of x. We're finding the derivative with respect to x. We all know the answer will be cosine of x, so let's run it. It gives you cosine of x. Gives you cosine of x. So this command is telling you that we're finding the derivative of sine of x with respect to x. And we're finding it only one time. But what if I want to find the second degree derivative of it? So we need to find x 2 times, right? So you can have x, and then we find x again. Simple. Or we can use our big brackets, finding x 2 times. So we know the answer should be negative sine of x, right? There you go, negative sine of x. Third degree derivative is the same, just change it to say 3, it's the same.
And so there's more convenient way to do it by just adding a.
Of course.
Yes.
But in this case, you need to define this function first. Let's see, we're up to f3 right now. f3, define about x is sine of x. It knows it now. f3 prime, remember the prime. We can use prime to represent derivatives as well. So f3 prime of x,
And you can
it
do
spits out the same function.
whatever times of prime you want. Like
You can also put in a word right now. You recognize the x is blue right now because Mathematica doesn't recognize it. That's why it's gonna spit out x. It's not gonna put in any random number at once. F prime of 3, let's get around pi over 2. It gives you a number. That is how Mathematica calculates the derivative at a particular point. For multivariable, it is the same thing. Just use the command of a prime. That is the same thing. So now let's move on to more interesting stuff. Let's move on to graphing. Graphing, there are a lot of commands built in Mathematica to allow graphing, but the most common one is plot. Plot is to plot a graph in 2-dimensional world. Let's have a very simple function, x squared. Just type it in everyday language. This is exactly how you would write it down if you only have one line to do it. Big brackets, because we're defining x and we're using like terms. What is in this big bracket is that I want to graph about x, and we want to have a range. Let's have a random -5 to 5. I always use this range. So it's telling it we're graphing about x from -5 to +5. You have this graph now. This is what Mathematica spits out for you. It is this graph of x squared from -5 to +5. This is plot. Well, it's not always 2-dimensional. It's not always this simple. So remember, there was one question in a previous quiz about to plot the contour lines of y times secant x. That's pretty difficult, and that's an implicit equation. So to plot an implicit equation, you can use contour plot. So contour plot is another variation of the original command plot, using for contour lines in 2Ds or implicit functions including 2 variables. So let's go back to that quiz question, y times secant of x. Now you need to define both x and y. You need to define both x and y. So now you need to give both x a range and y a range. Still using big brackets, x from -5 to 5, see how it changed colors, and y from -5 to to positive 5. It gives you this graph. These are the contour lines, and when your mouse touches them, it gives you those values of those contour lines. -20, -10, -5. Which is very simple. And also, this is also the way how you graph a circle if you don't want to split it into two equations doing square roots and stuff. Another thing we have is parametric plot. It is used to graph a parametric equation in 2 dimensions. Let's say we define x equals to 2t minus 3 and y equals to t squared plus 8. How are we supposed to plot it? Well, these are all equations defined with t, so they are like terms, so we use a big bracket. And now we enter them with those like terms, so we said x equals to 2t minus 3, y equals to t squared plus 8. Now, it doesn't recognize t, so we need to define t on a range. As any other plots, t from -5 to positive 5. This is how you define the range. And hey, it gives you this plot. It gives you the graph of this function. It looks like parabola, we don't know if it's actually one or not. So these are some basic plots from 2-dimensional. And also 3-dimensional plots are really similar. You just add in 3D after these commands. Like plot 3D is the command that you would use to plot a 3-dimensional equation that is defined as z equals to x blah blah blah, y blah blah blah. But when you meet an implicit function, you go for a contour plot 3D. And a parametrized 3D 3-variable equation will be parametric plot 3D. So these are all built-in commands that Mathematica has if you want to graph. One last command that we're going to talk about today is polar plot, which graphs the function in a polar, in r versus theta, in a polar coordinate system. Let's take a very simple equation, sine of theta, r equals to sine of theta plus 1, let's say. We define this function sine of theta. I'm gonna put theta later because that's also an important point that I want to talk about. The range, let's say from 0 to 2 pi. Okay, now I'm gonna talk about how to type theta in Mathematica, and also a lot of other special characters like omega, alpha, beta that math commonly use. We want a theta over here. We type the backslash, brackets, capitalized T for theta. Boom, here you go. Remember, it must be capitalized because Mathematica also recognizes as a command. Same here, backslash, brackets, capitalized T, theta. There you go. I probably should delete this because otherwise they're going to be in the, no, I'll just leave it there. There you go, your graph. It's very simple. So Mathematica is this kind of, it's just this kind of software that is real simple. It has a bunch of built-in commands like what we just talked about, like matrices, eigenvalues, transpose. These are all built-in commands. It's really similar and really simple. Just one line of those, and you can do it.
And there's also one very useful command, which is dash plus dot. That means substitute all for x. Like you want a value for goes to 5x. Whatever.
Yeah, whatever. Okay, so let's have a little bit of fun right now.
Yes.
Have a little bit of practice.
Do some practice time. So go on to practice. You might get a bonus point for it.
Yeah, I might get a bonus point from Mr.